Continuation of that one we are going to see here. Okay, so already we said we can solve this integration in two ways. One of the ways is nothing but just by applying integral uv. So this is the formula. I think it is better to learn this formula. Easily you can solve it if you have product of two functions. And one more thing, one of the functions should be terminate. Okay, so then only we can apply this one, minus u dash v2 plus u double dash v3 minus u double dash v3 minus and so on. Okay, so this is the one you can apply. So here it is, what we can choose. This is u is equal nothing but we can choose x power 4, and next u dash is nothing but simply what we can write. So one time derivative of this one, so one time derivative is nothing but 4x cube, and next again two times derivative of this one. So 2 times derivative is nothing but 4 into 3x square, that is nothing but 4 into 3 is 12, so 12x square. And next u the triple dash, it means 3 times derivative of this one. So 3 times derivative is nothing but simply what we'll get, 12 into 2x, that is nothing but 24x, and 4 times derivative of this. So 4 times derivative of this one is nothing but simply what we'll get, 24. It means we need to write the formula up to 4 times derivative of u. And next here it is, here what about v? So v is equal what we chosen, e power minus x by 10, right? So one time integration of this one, so one time integration of this one is nothing but what we'll get, e power minus x by 10 as e power minus x by 10 by the derivative of x by 10 is nothing but simply what we'll get, minus 1 by 10. So this is the formula we'll get, right? So one time integration, and in the same way two time integration is nothing but simply what we'll get, e power minus x by 10, and next minus 1 by 10 whole square. So minus 1 by 10 whole square, and next 3 times integration of v. So 3 times integration of v is nothing but simply what we'll get, e power minus x by 10. So that is simply we can write by minus 1 by 10 whole cube. So minus 1 by 10 whole cube. So this is the one we can apply. And next 4 times integration of this one is nothing but e power minus x by 10 minus 1 by 10 whole power 4. So my power minus x by 10 minus 1 by 10 whole power 4. In the same way next we will get it as v5. So 5 times integration of this. So simply what we'll get, e power minus x by 10 minus 1 by 10 whole power 6. So minus 1 by 10 whole power 5. So this is the one. So here it is formula up to what we'll get, minus 3 times derivative of into 4 times integration of this, and next plus 4 times derivative of u and 5 times integration of v. Okay, so here it is up to what we are applying, 4 times derivative. So formula you can write up to this one. Simply we can substitute all those things, and between the limits 0 to 60. Maybe little bit complication will become. Why? Because 60 is here. So by using calculus you can easily calculate it, that one. So large values it will come. When you are substituting, please take care of that. So this is one way. And another way is nothing but this is the way. So substitution method. So previous problem also same as this. We used this is the formula we used in that. Either you can use this formula or simply you can take substitution. So here it is, x put x by 10 is equal to t. So it means we are converting the variable x in terms of t. So that implies by cross multiplying simply what we are getting, x is equal to 10t, and differentiating on both sides, then simply what we are getting, dx is equal to 10 dt. Now this is assumption we chosen, and we are converting in x in terms of t. Now we need to find the limits of t. These are the limits of x. So here it is, x by 10 is equal to t. So that one we took assumption. So first when x is equal to 0, what we will get? So x is equal to 0, simply what we will get, t is equal, you have to substitute in place of x as 0. So 0 by 10 is nothing but simply what we will get, 0. So when x is equal to 0, t is equal to 0. And next one, when x is equal to 60, so t is equal, what we will get, 60 by 10. So 60 by 10 is nothing but what we'll get 6. It means x varies from 0 to 60 and t varies from 0 to 6. Now we need to substitute all those things in that. By substituting in that, simply what we'll get 0 to 6 x power 4. So x power 4 is nothing but x what we chosen here 10t. So 10t whole power 4, and next e power minus x by 10. So x by 10 is nothing but what we chosen t. So e power minus t, and dx is here. So dx is nothing but what we get 10 dt. So then dt. So this is the one we got it. Now here it is, if you observe this one, ab whole power m is nothing but a power m b power m. It means simply what we'll get it there 10 power 4, and already there it is having 10. So a power m into a power n, that is nothing but 10 power 5. Okay, so already here it is having 10 power 5, and this 10 power 5 cancel. And what will get remaining here it is 1 by 4 factorial, that is nothing but 4 factorial is 24, 4 into 3 into 2 into 1, and integral 0 to 6, and remaining here it is having t power 4 e power minus t dt. So this is the remaining one. Now 1 by 24 into, so again what we can apply the formula, same this formula we need to apply, integral uv dx. Okay, so t power 4 is nothing but same derivatives will get as it is. Okay, only the change is here, no need to write every time x by 10 x by 10 like that. Okay, so simply if you write the form, apply this formula, u is nothing but t power 4, and next v1. So one time integration of this one is nothing but simply what we'll get e power minus e power minus t. Same the as is these things none. So in place of x by t, simply we are writing as t. Okay, and here it is constant, there it is having 1 by 10. So for the denominator we got it as 1 by 10, but here it is having 1, so minus 1. Okay, next minus t power 4 is nothing but 4 one time derivative, simply what we get 4t cube, and next integration of this one is nothing but simply what we'll get e power minus t. Next plus 4t cube derivative is nothing but 12t square. So 12t square, and e power minus t integration is minus e power minus t. Next 12t square derivative is 24t. So 24t into e power minus t. Again if you apply integration. Next plus 24t derivative is nothing but 24, and e power minus t integration is minus e power minus t. And with that we can close that formula, and we can substitute the values. So here it is, the limits are from 0 to 6. It means first we need to substitute in place of t as 6, and then we have to substitute in place of t as 0. Okay, then we can calculate by using calc. Calc is mandatory for getting the values e power minus 6. Okay, so you need to know that how to use the calc also. Calc operation is also very important. Okay, so this is the one, and finally you'll get the value, and we are calculating probability. Obviously that should be lies between 0 to 1. Okay, so this is the problem. So here only one thing, just first we have to write the formula of gamma function, gamma distribution. After writing the formula, simply what we are doing, after writing the formula, we need to know the values of alpha and beta. So these are the parameters of gamma distribution. These are the parameters we require. Okay, alpha and beta parameters are required. If you know those values, simply substitute those values in gamma distribution and then substitution. So what the thing is, there it is having the formula is applicable for x greater than 0. It means 0 to infinity. So 0 to infinity means based on the problem we are splitting the interval. So 0 to 60, 60 to infinity. If you see the previous problem, 0 to 1, 1 to infinity, like that. After splitting as usual, same like as continuous distribution. Okay, so here it is. See that, did you get that one or not? Here it is, it's 0, and we applied t power 4 e power minus t, and we have to substitute the values of 6. So what we did here it is, so this first we chosen e power minus t as the common one, and remaining we wrote here it is. Okay, so minus t power 4 minus 4t cube, and here it is minus 12t square minus 24t, and if you substitute lower limit, this is 0, 0, and this is also 0, and here it is e power 0 is nothing but 1. So for that minus 24. Okay, so actually minus not 24, so this is the people will get it as plus 24. Why? Because lower limit we are substituting, obviously minus become plus. Okay, so then plus 24, and here it is, we wrote that one of plus 24, and then after calculating this, simply what we got it here, 0.715. Okay, so this is the value. Just simplification, you need to know that how to apply integration. Next one, it is known from previous data that the length of the time in months between customers' complaints about a certain product is a gamma distribution with alpha is equal to 2 and beta is equal to 4. So simply same like this, if they mention the formula, it is very happy. Why? Because simply we can substitute those values in the formula and we have to calculate. But you need to know that what we need to calculate. So here it is what they mentioned. It is known from previous data that the length of time in months between customers' complaints about a certain product. Suppose if you are manufacturing a product, okay, so after manufacturing, obviously some defectives will be there in that particular product. Okay, here it is complaints they will So customers complained about a certain product. We are taking as a gamma distribution, not that time in months between the length of the time. It means that suppose if people give complaint today, okay, and next they rectify that problem after 1 month or 2 months or 3 months or 1 week, okay, between that time, okay, so time in months, they are saying about months. It means they are clearing that complaint in months variation. It means 1 month they may take for clarifying that, and 2 months you may take. Suppose if you are taking in your homes, okay, so freeze or AC, so same like that. So something repair comes, then immediately people call to customer care, and that people will come and they repair that one. Okay, so they take the time, right? Immediately they never come. Maybe one month or 10 days. Okay, like that. Here it is, they are saying months. Okay, between customer complaint and their services. Okay, is simply what they are defining, gamma distribution with parameters alpha is equal to 2 and beta is equal to 4. Changes were made that involving a tightening of quality control requirements following these changes. Okay, it took to 20 months before the first complaint. Does it appear as if quality control tightening was effective? So it means that they are saying that quality control in the sense, so customer care, right? So that quality control committee will come and they will check it that one, what is that? So it takes how much, 20 months before the first complaint. So before 20 months for repairing that one, we need to calculate that one. It means simply what we need to calculate here is P of x greater than or equal to 20. So how much time it takes, for what is the possibility for getting more than 20 months? Okay, so that is simply we need to calculate here. That only here we are writing first, let x be the time to the first complaint. So just we are defining that, which under conditions prior to the changes follows a gamma distribution with values alpha equal to 2 and beta is equal to 4. So just we wrote the explanation for that one. So simply the question centers around how rare is x greater than or equal to 20. So a question మొత్తం కూడా more than 20 months అయితే, so what is the possibility that one, given that alpha and beta remains of values 2 and 4 respectively, so time to complaint as large as 20 months reasonable. Okay, so what they mentioned in the question, simply we wrote here. Thus we need to follow in the solution. Here it is gamma distribution, they clearly mentioned, so we need to use the formula of gamma distribution. So what is that formula we are using? 1 by, so beta power alpha gamma alpha x power alpha minus 1 x power alpha minus 1, and next here it is e power minus x by beta, and this is applicable, we are taking as x greater than 0 and less than 0, equal to 0, otherwise rest of the cases. So here it is, we are going to calculate this one, but so 20 to infinity we can't take that one, so up to finite value we require. So for that simply we know that by using this one, total area under the curve is 1. So simply by using that we are writing as 1 minus p of x less than 20. So x less than 20 is nothing but generally as per this one up to what we are taking 0 to infinity. But we are breaking that point at which point 20, right? So it means 0 to infinity and 20 to infinity. So but we can't measure this one. So for that simply what we are calculating 0 to 20 we are calculating. So that is only p of x less than 20. So x less than 20 means is generally what you will think minus infinity plus infinity. But this is applicable only for increasing functions and x greater than 0 onwards. So for that 0 to 20, 1 by beta for alpha gamma alpha x for alpha minus 1 e power minus x by beta. Already we know the values of alpha and beta. So alpha how much they give? 2 and beta is equal to how much? 4. So that is simply we have to substitute here. So by substituting simply what we are getting 1 minus 1 by beta for alpha is nothing but 4 square. So 4 square and next simply gamma alpha. Gamma alpha is nothing but 2 integral 0 to 20 x power alpha minus 1. So x power alpha is nothing but 2. So alpha minus 1 and e power minus x by beta. So minus x by 4 dx. So this is the one we are going to calculate. So 1 minus 1 by, so 4 square is nothing but 16 and gamma 2 is nothing but. So already we calculated. So we already said gamma 4 is nothing but simply what we have to write 3 into 2 into 1. Okay. In the same way gamma 90 is nothing but. It starts from what? 89 onwards. So 89 into 88 into 87 into and so on up to how much we'll get? Up to 1 will get it. In the same way gamma t is nothing but 1 into 1. So into 1 and integral 0 to 20 and here it is what we'll get x into e power minus x by 4 dx. So x into e power minus x by 4 dx. So simply what we can write 1 minus 1 by 16 and same UV formula you have to apply x into e power minus x by 4. That is nothing but simply what we can write e power minus x by 4 by minus 1 by 4. And next minus the derivative of x is 1 and integration of this one is nothing but what we'll get again e power minus x by 4 by minus 1 by 4 whole square. So minus 1 by 4 whole square between the limits here it is 0 to 20. So simply if we substitute in that what we'll get 1 minus 1 by 16 into and first we have to substitute in place of x as 20. Then it comes to numerator. So simply what we get minus 4 into 20 into e power minus 20 by 4. So minus 20 by 4 and next here it is again you will get it as minus 16 into e power minus 20 by 4 if you substitute upper limit. And next coming to lower limit. Here it is 0. So 0 and anything 0. And here it is minus become plus. So 16 into e power minus 0. So 0 by anything is 0. So it means finally what we'll get 1 minus 1 by 16 into here it is 20 into 4. So minus 80 e power minus 5 and this is minus 16 e power minus 5 and plus 16. So this is the remaining one. So we need to calculate this one now. So by using calculation people have to calculate this. After calculation of this one you get the value which is lies between 0 to 1. Okay. So this is the one we need to solve. So simplification as usual previously what you solve the problems in continuous random variables. The thing is only you need to know that formula you should remember and alpha beta what they give. See here same we got it. No, simply what we solve. Is it right or not? Okay. Next, suppose that the time in hours taken to repair a heat pump is a random variable capital X having a gamma distribution with parameters alpha is equal to 2 and beta is equal to 1 by 2. Suppose the time. So here also they are taking the time in hours taken to repair a heat pump. So here it is they are repairing product, some product. What is that product? Here they chosen heat pump. Okay. So heat pump they are taking they are doing a repairing. Okay, for repairing how much time they are taking, suppose they are measuring in time, and the time also they are measuring in hours. Okay, it means that for repairing heat pump, so maybe 2 hours or 3 hours or 4 hours, that one they mentioned here, it is alpha is equal to 2 and beta is equal 1 by 2. Okay, and it is represented as a gamma distribution they are taking. Then what they're asking, what is the probability that the next service call will require? Okay, the next service call is in the sense for repairing next one, for providing service for next product. Okay, next product is nothing but, suppose 10 products are there. Here 10 heat pumps are there. So first they is repaired that heat pump, and next for providing service for second one, the time taking how much? Okay, next third one, next fourth one, like that, will require at most 1 hour to repair the heat pump. So what is the possibility for repairing at least 2 hours and at most 1 hour? Already we know that at least, at most, so these terminals is very important, already we saw that. So p of, simply what we need to calculate, at most is nothing but p of x less than or equal to 1, and here it is at least is nothing but, simply we have to calculate p of x greater than or equal to 2. So these are the two values we need to calculate. Okay, and alpha they give and beta also they give. Okay, so formula also we know that. So this is simply we can calculate it, which is equal integral 1 to 0 to 1 we can calculate it. And this is nothing but simply what we can write, 1 minus p of x less than 2. So x less than 2, so this is nothing but 1 minus integral 0 to 2 we have to calculate at least and at most. So these are the things we are going to calculate. Okay, so here clearly you need to know that what we are doing, they are repairing a heat pump and they are taking a time, and that time they are measuring in hours. Okay, with parameters alpha equal to 2 and beta is equal 1 by 2. And next, what are the possibilities for taking repair at least 1 hour for heat pump, or at most sorry, at least 2 hours and at most 1 hour. Okay, so if you want you can change the values and you can calculate this one. Okay, so this is the one we are going to see here. So first, x random variable, what they mentioned, time in hours taken to repair a heat pump, and alpha is equal to this one, beta is equal 1 by 2, and by gamma distribution this is the formula we are using, 1 by beta power alpha x power alpha minus 1 e power minus x by beta x greater than 0. So p of x less than or equal to 1 means, here it is actually continuous means we are discussing about minus infinity to plus infinity, right? So continuous random variables. But here it is, as per the definition, simply what we are saying, this density function is applicable between the interval only from 0 to infinity, and rest of the cases this is 0. So for that, as per the problem, here it is having 1 we require. So here it is 1. So we are going to calculate less than or equal to 1. It means up to what? This one. So this is also simply you can write like minus infinity to 1. So like this you can write minus infinity to 1 plus 1 to infinity. Okay. So minus infinity to 1 plus 1 to infinity, like this we can write. But here it is as per the problem, as per the definition, simply minus infinity to 0 and 0 to 1. So again we need to split this one, 0 to 1. So minus infinity to 0 is nothing but how much, here it is having 0. So for that this is 0, and next is 0 to 1. So 0 to 1 we know that the with parameters what they give, so that is 0 to 1. Okay, and 1 to infinity we can't measure that one, so that's why we are, that is also obviously 0 as per the problem. Okay, now we are going to substitute all these values in that. So this is equal integral 0 to 1 1 by beta power alpha. So beta is nothing but how much they give, 1 by 2. So 1 by 2, alpha is nothing but what, 2, and gamma alpha is nothing but 2, x power alpha minus 1. So alpha is nothing but how much they give, 2 e power minus x by beta. So x by beta is nothing but what, 1 by 2 dx. And this is the easiest one for calculation. So 1 by beta power alpha is nothing but 1 by 2 whole square is nothing but simply what we get, 1 by 4 and this one goes to numerator, and gamma t is nothing but just previous problems we saw that value is 1 and integral 0 to 1 whatever remaining x into e power minus 2x dx, x into e power minus 2x dx. So 4 into, so apply the derivative, apply uv formula for this one, x into e power minus 2x, integration is e power minus 2x by minus 2. So this is the one. Okay, between my next minus the derivative of x is 1, and next integration of this one simply will get it as e power minus 2x by minus 2 whole square. So simply this formula we are applying uv. So u into v1 minus u dash v2. Now you can substitute the values in that. 4 into, here it is, minus 2 is a constant, and if you substitute 1 we'll get it as 1 by 2 e power minus 2, and here it is minus 1 by 4 e power minus 2. If you substitute the value is 1, and if you substitute lower limit 0, so 0 and anything is 0, and here it is minus become plus 1 by 4. So this is the value we'll get. Okay, so by simplifying this you'll get the value. Okay, that's it. This is for at most 1. In the same way, at least 2 hours is nothing but simply what we have to calculate, p of x greater than or equal to 2. That is simply we can write 1 minus p of x less than 2. So 1 minus p of x less than 2 is nothing but simply what we can write, 1 by beta power alpha gamma alpha, and next integral 0 to 2, integral 0 to 2 x power alpha minus 1 e power minus x by beta dx. So e power minus x by beta dx. Simply what we can write, 1 minus beta power alpha gamma alpha, as it is this one, there is no change in that. It means what we got the value 4, integral 0 to 2, and here it is also same like that, x power alpha minus 1 2 minus 1 1, and e power minus x by beta is nothing but minus 2x dx, e power minus 2x dx. Only the change here and there, interval 0 to 1 0 to 2. It means simply what we'll get, 1 minus 4 into, same as it is this, no. So here it is, but in place of x we have to substitute as 2. So 4 into minus 2 by 2 e power minus 4, and next one minus, here it is having 1 by 4 e power minus 4, and next simply again you will get as it is plus 1 by 4. If you substitute 0, as it is will get. Okay, so this is the one. Okay, so with this one we need to calculate 1 minus 4 into, here it is having, you will get it as minus 5 by 4 e power minus 4, and next plus 1 by 4. So if you simplify this one, if you take LCM, 4 is the LCM, 4 4 cancel, and simply what will get, 1 minus of 1 minus 5 into e power minus 4. This is the value you get. You have to calculate by using calcs. Okay, so that is, so even though this one also if it is multiplied, so 1 minus 1 both will cancel, minus into minus plus, and final answer will get it as 5 into e power minus 4. So this is the value you need to calculate. Okay, so only you need to understand the question, then the process, procedure, everything how you solved it, continuous, same as this. Same this one we got it now. Next, here it is. This one we solve 5 e power minus 4, right? This is the value 0.09157. Next problem, in a certain city, the daily consumption of water in millions of liters they are taking follows approximately a gamma distribution. It means that if you are taking a Hyderabad, or if you are taking Karimnagar, or like that. So suppose they are taking a city, okay, the daily consumption of water. So how much water is that entire city is taking per day, okay, in millions of liters they are measuring, follows approximately gamma distribution with alpha is equal to 2 and beta is equal to 3. If the daily capacity of that city is 9 million liters of water, okay, so per day how much water that city is spending, that city is consuming 9 million liters of water is taking daily. Okay, so it means per day 9 liters water, 9 million liters of water they are using. Okay, what is the probability that on any given day the water supply is inadequate? Okay, so here the already said no meaning is important. What is the probability? It means possibility they are asking that on any given day. So any one particular day, they are not mentioning that the water supply is inadequate. It means the water supply uh, is is properly not using. Okay, it means that antakante takkuvam, so less than that. Okay, so is it possible? How many possibilities? What are the possibilities are there? Inadequate in the sense less than. Okay, so less water. So less water is nothing but they mentioned clearly already how much water they are using per day. 9 million liters of water. So if suppose if it is less than that, is it possible for what is the possibility? What are the possibilities for that if it is less than 9 liters? Okay, so that is the one we are taking, and we are giving we are discussing entirely random variables. So for that first we what they gave the information, that one we are choosing as X. Here it is. Okay, so X is equal the daily consumption of water in millions of liters. Then X follows gamma distribution, and already they give alpha equal to 2 and beta is equal to 3. And what they mentioned in the problem, that one we wrote, the daily capacity of the city is 9 liters of water. So next, P of water supply is inadequate. This is the one we are going to calculate. So water supply is inadequate in the sense, suppose the water came less than 9 millions of water. So what are the possibilities? Okay, inadequate is nothing but insufficient. Okay, then P of x less than 9. So P of x less than 9 is equal, simply we are going to calculate 0 to 9 f of x dx. So as usual remind. So 1 by beta power alpha, gamma alpha and x power alpha minus 1 e power minus x by beta. So that is nothing but 0 to 9, and already beta is nothing but how much they give? 3, and alpha is 2 and gamma 2, x power alpha minus 1. So x power alpha is nothing but here it is 2 minus 1 and e power minus x by beta. So minus x by beta is nothing but 3. That's dx. And now here it is simply what we can write, 1 by 9 integral 0 to 9, and simply here it is writing x power 2 minus 1 is nothing but x and e power minus x by 3 dx. So this is, and now we are going to calculate this one, 1 by 9 into same formula you can use it now, x into e power minus x by 3 is nothing but e power minus x by 3 by minus 1 by 3. So this is the one, and next minus x derivative is nothing but 1 and integration of this one, e power minus x by 3 by minus 1 by 3 whole square. So minus 1 by 3 whole square between the limits 0 to 9. It means simply what we'll get, 1 by 9 into, if you substitute in place of x as 9. So this one also comes to numerator, minus 3 into 9 into e power minus 9 by 3 now. So it goes 3 times. So here it is minus 9 into e power minus 3, and then if you substitute lower limit 0. So this one completely 0. Why? Because 0 and anything 0, and this minus become plus. So plus 9. So it means simply what we are getting, 1 by 9. So 9 is the common one, and you can cancel this, and simply what we'll get, minus 3 e power minus 3 minus e power minus 3. It means simply we get it as 1 minus 4 e power minus 3. So this is the possibility we need to calculate. Water supply is inadequate. So see that, did you get that one or not? So 1 minus 4 e power minus 3, right? So 1 minus 4 e power minus 3 is 0.8008. So this is the possibility for water supply is inadequate. Next one. In a biomedical research activity, it was determined that the survival time in weeks of an animal when subjected to a certain exposure of gamma radiation has a gamma distribution with alpha is equal to 5 and beta is equal to 10. Same like as previous one. Okay, so previous problems we got it the same type of this one in rats survival rate. In the same way here it is they are saying In a biomedical research activity, it was determined that the survival time in weeks, okay, of an animal when subjected to a certain exposure of gamma radiation. It means that suppose rats or monkeys or donkeys, whatever it is, first they are choosing as they chosen some animal, they didn't mention the animals, and they are giving certain exposure of gamma radiation. It means they are giving radiation to those animals. Okay, after giving the radiation, their survival time, so survival time they are saying here in weeks. Okay, it means after giving the radiation, how many weeks those animals are surviving, it means living. Okay, suppose like as now we are the our scientists are doing some coronavirus, right? So first they give that one to some animals. Okay, so after giving the animals, how many weeks they are surviving, or some persons also they are giving right now. Okay, so they are selecting some voluntarily some people, and they are injecting that injection to them, and they are checking, okay, whether it is working or not. They are seeing the 15 days observation, okay, or 1 month observation they are taking. In the same way here it is, certain radiation they are giving to animals. After giving the radiation, how many days those animals are surviving, and that time they are saying in weeks, that maybe 2 weeks or 3 weeks or 5 weeks. Okay, with alpha is equal to 5 and beta is equal to 10. And what they are asking here, what is the mean survival time of a randomly selected animal of the time used in the experiment? So it means on an average, what about their survival time, randomly selected animal of the time. It means after giving the radiation, some animals are there, so randomly one animal they are selecting, and they are asking to find average, what about their survival time. What is the standard deviation of survival time? So standard deviation they are asking. And what is the probability that an animal survives more than 30 weeks? What is the possibility? Okay, it means we need to calculate here, it is p of x greater than 30 weeks, so that one we need to calculate. So these are the things we are going to calculate here. It means simply what we are going to calculate here, mean, standard deviation, and p of x greater than or equal to 3. So total three things we are going to calculate. Here it is mean we are calculating, that is nothing but mu we are going to calculate. And next standard deviation is nothing but sigma we are going to calculate. Okay, so these are the two things. And third one we are going to calculate p of x greater than 30. So this is directly 30 to infinity, so better than that, simply we can use to calculate 1 minus p of x less than or equal to 30. So 1 minus p of x less than or equal to 30. So this one also we can calculate. Okay. So these are the things we are going to calculate. It means mean of the which distribution we are taking, gamma distribution, and standard deviation of the gamma distribution we are going to calculate. Okay. So those are the things we are going to calculate, mean, standard deviation, and p of x greater than 30. So first we are choosing x is equal survival time in weeks of an animal when subjected to a certain exposure of gamma radiation, and x follows a gamma distribution, and next we wrote here alpha is equal to 5 and beta is equal to 10. And mean, first we have to calculate average survival rate of randomly selected animal. Mu is equal, that is nothing but what is the formula we are using for mean of a gamma distribution, alpha beta. So here it is, alpha is 5 and beta is 10. So that is nothing but 50. So it means on an average those animals survival time is 50 weeks. 50 weeks. And next standard deviation is nothing but, so variance we know that, variance we calculated. So variance we know that alpha beta square, and here it is sigma is nothing but square root of alpha beta square. So sigma is equal to square root of alpha beta square root of alpha is nothing but how much, 5, and beta square is nothing but, beta is here it is having 10, so 10 square. So it means, so root 5 and into 10 square is nothing but 100, and 10 square root will cancel, 10 root 5. Okay, so this one on an average. So this is standard deviation. And next third one we are going to calculate p of x greater than 30. See here alpha beta 50 weeks, and next here it is alpha beta square, and next here it is 500 and sigma is equal square root of 500. And next more than 30 weeks, so simply we calculated 1 minus b of x less than or equal to 30. It means 1 minus integral 0 to 30 f of x dx. Okay, so f of x is nothing but density function, here it is we are using. So 1 minus 1 by beta power alpha. So beta power alpha is nothing but beta is there, it is having 10 power 5, and next gamma alpha. So alpha is 5, so gamma alpha, and next integral 0 to 30 x power alpha minus 1. So x power alpha is nothing but here it is 5 minus 1 4, and e power minus xy beta is nothing but 10 minus x by 10 dx. And now simply what we can write here, it is 1 minus 1 by 10 power 5, and gamma 5 is nothing but simply what we discussed, 4 into 3 into 2 into 1. Okay, and integral 0 to 4 this one. So it means we need to apply integration for this x power 4, and same as it is we got it right, integral 0 to 60 x power 4 e power minus x by 10 dx. First what we discussed in this today's one. Okay, x power 4 e power minus x by 10. So that one here as it is 0 to 30. Or if you want to simplify that one, what we chose an assumption there, put x by 10 is equal to t. That one we can apply. Okay, so why simply calculation part completely. So that only here we did see x power 4 e power minus x by 10, put x by 10 is equal to t, or simply you can apply, of course after converting into variable t also we are applying the same formula, Bernoulli's formula, integral x u v, same formula, only for reducing that in place of the x by 10, for reducing that one we are doing. Okay, so this is completely calculation form. Next, the lifetime in weeks of a certain type of transistor is known to follow a gamma distribution with the mean 10 weeks and standard deviation root 50 weeks. Okay, so opposite now. So there it is alpha value, beta value they give in previous problem, and here it is there are they give mean they give and standard deviation they give. So mean they give and standard deviation they give. So these are the two things they give. So here it is, mean is nothing but mu and standard deviation is nothing but sigma. So mu is nothing but simply what we are writing, alpha beta. So alpha beta is equal to 10 they give, and next standard deviation is nothing but square root of alpha beta square, right? So square root of alpha beta square is equal square root of 50. So these are the two things they give. Here it is, square roots both will cancel, then simply what we'll get, alpha beta square is equal how much, alpha beta square is equal 50. So this one they give, from this we can calculate alpha and beta, right? So here it is, we can divide both. So then alpha beta square by alpha beta and 50 by 10. So here it is, alpha alpha both will cancel and 1 beta cancel, and 10 5s are here it is. Then simply what we'll get, beta is equal to 5. So this is the value of beta. By taking this value we can get the value of alpha, right? So 5 into alpha is equal 10. So alpha is equal 10 by 2. So 10 by 5. So 10 by 5, so which is simply what we'll get 2. So what we got the values here, beta is equal to 5 and alpha is equal to 2. Previously they gave alpha beta and we calculated mean and standard deviation. Here it is mean and standard deviation they give, by using that we calculated alpha and beta. Okay, this is, and they are discussing about here it is transistors lifetime. Okay, so if you are buying a mobile, whatever that lifetime, it lays one year they manufacture battery. Okay, in the same if you buy for printer, computer, laptop or whatever the product it is, it having a certain lifetime they'll give warranty. Okay, so in the same way transistor they are giving a lifetime in weeks. Okay, so on an average the transistor's lifetime is 10 weeks, and with the standard deviation root 50 weeks. Then what they are asking to calculate here, what is the probability that, so probability they are asking to calculate the transistor will last at most 5 weeks. At most in the sense what we know that. At most is nothing but less than or equal to 5. So this is the one we need to calculate. It means simply what we need to calculate integral 0 to 5 f of x dx. This is the one we need to calculate. So this is the first problem. And next one what they asked to calculate here it is. Next one, what is the probability that the transistor will not survive the first 10 weeks? Okay, so on an average 10 weeks they give, but here it is they're asking to calculate less than 10 weeks, it damaged. Okay, it damaged. What is the possibility for that? Will not survive in the sense it doesn't work. Okay, it means simply what we need to calculate P of will not survive none. So and it means that less than 10 weeks, right? So P of x less than 10 weeks. Okay. So that is only here we are going to calculate. Just now we saw that mean is equal to 10, alpha beta equal to this, alpha beta square, and we divided those two, and what we got it here, alpha equal to 2 and beta equal to 5. And first one at most is 0 to 5, 1 by beta power alpha gamma alpha x power alpha minus 1 e power minus x by beta. Same, just we can substitute the values here and then simplifying that. 1 by 25 x e power minus x by 5 and calculating that. In the same way next, P of not survive 10 weeks. It means 1 minus P of survive 10 weeks is nothing but simply what we can calculate 1 minus P of x less than 10. So simply what we can write 1 minus 0 to 10, 1 by beta power alpha gamma alpha x power alpha minus 1 e power minus x by beta, and simplifying that same as usual just like as previous one. And this is the last problem. We'll see that gamma distribution. With that, we'll close this gamma distribution problems. In a certain city, the daily consumption of electric power. In previous, what we saw that water, and next electric power. It means water bill, electricity bill. In millions of kilowatt hours is a random variable x having gamma distribution. Here also same like as previous one. Alpha, beta they give, mean they give, and variance they give. Okay, find the values of alpha and beta. Next, find the probability that on any given day in the sense any particular day, the daily power consumption will exceed 12 million kilowatt hours. Okay, so will exceed is nothing but greater than none. So it means simply we need to calculate less than that. So here it is simply what we can write here it is mean they give. So mu is equal to alpha. That is nothing but alpha beta is equal to 6 they give, and variance is nothing but alpha beta square. So alpha beta square is equal nothing but simply 12. So by dividing this, okay, this one or the first one, second one, or second one, first one, you can divide any one of these. Okay, if you divide same like this, simply alpha alpha cancel, one beta cancel, and this is 6 ones and 6 twos. It means simply what we'll get 1 by beta is equal 1 by 2. So this is the one we got it. From this simply what we can write beta is equal to how much 2. So beta is equal to 2, and alpha beta already we know that alpha beta is equal nothing but 6. By substituting our beta value as 2, then 2 alpha is equal to 6. Alpha is equal 6 by 2, that is nothing but simply what we got it, alpha is equal to 3. So alpha 3 and beta 2. And next second one what we need to calculate probability only. So P of on any given day will exceed is nothing but exceed is nothing but more than, so 12 weeks. So that is simply what we need to calculate 1 minus P of x less than 12, x less than or equal to 12. So this is simply what we can write 1 minus, here it is simply we can write 0 to 12 1 by beta power alpha. So that is nothing but 2 cube, and gamma alpha is nothing but gamma 3, that is nothing but simply we can write 2 x power alpha minus 1, that is x square, and e power minus x by beta, so minus x by 2 dx. This one as usual calculation again. Okay, so this is the one we are going to calculate. These are the two things we are going to calculate, right? So see here, first without x defining, and next x mu is equal to this, and alpha 3 beta 2 we got it, and 1 minus p of x less than or equal to 12. Simply we got it. Now 8 into gamma 3 is nothing but 2 factorial, and again uv formula here we are applying. So uv1 minus u dash v2 plus u double dash v3, and substituting the limits 0 and 12 in that. Okay, so by simplifying what we got it, 25 e power minus 6. So this is equal to 0.0616. Here only one thing we have to know that what is that. First you need to understand the question clearly. What is the information they give? After understanding that question, you need to identify the parameters of gamma distribution, alpha and beta. After identifying those two, we need to calculate what they asked. For that, we are using only single formula. Okay, 1 by beta for alpha, gamma alpha, integral 0 to alpha, of course 0 to infinity, x power alpha minus 1 e power minus x by beta dx. That is valid only for x greater than 0. For rest of all the cases, that is 0. And then simplifying. So for simplification also we are using only one formula, integral uv dx or assumption method. So that is it. So this is the gamma distribution problems. Next we will see that problems on exponential distribution. Okay.